Forces and balance. So, a force is a pull or push exerted by one object on another. It has a direction as well as magnitude, so it's a vector quantity. The SI unit of force is the Newton, and we use a spring balance to measure force. Small forces can be measured using a spring balance like this one. The greater the force, the more the spring is stretched and the higher the reading on the scale. So here I have some common examples of forces. First we have frictional force, then we have gravity, magnetic force, applied force, the upthrust of water, this is also a force, the weight of the boat, it's also a force, tension force, which is also called elastic force, the drag force, also called air resistance, and the spring force, the force which is in springs. So these are some examples and types of forces. On Earth, unpowered vehicles soon come to rest because of friction. But with no friction, gravity or any other external force on it, a moving object will keep moving forever at a steady speed in a straight line. It doesn't need a force to keep it moving. This idea is summed up in a law first put forward by Sir Isaac Newton in 1687, known as Newton's first law of motion. The law states that if no external force is acting on it, an object will, if stationary, remain stationary, and if moving, will keep moving at a steady speed in a straight line. This is known as Newton's first law. Now let's look at some balanced forces. This law will come into them as well. So an object may have several forces on it, but if the forces are in balance, they cancel each other out. Then the object behaves as if there is no force on it at all. So as you can see, this gymnast has balanced herself on this beam nicely. So because she is balanced, there is no force acting on her at all. As Newton's first law states, if no external force is acting on it, an object will, if stationary, remain stationary. So this rule applies over her because as she is stationary, she will remain stationary in this position. And ice skaters make use of this law as well, because when they skate, they balance themselves at a position where the forces cancel each other out. And if they are moving, they will keep moving at a steady speed in a straight line. This is how ice skaters keep moving even when they are not moving their body at all, or they have a same position, they're still moving on the ice. So Newton's first law of motion is the reason of all of this. That if no external force is acting on it, an object will, if stationary, remain stationary, and if moving, keep moving at a steady speed in a straight line. Now let's look at terminal velocity. So when a skydiver falls from a hovering helicopter, as her speed increases, the air resistance on her also increases. Eventually, it is enough to balance her weight and she gains no more speed. She is at her terminal velocity. So basically, her weight and the air resistance cancel each other out when they become equal to each other. So they cancel each other out and she gains no more speed. So she is at her terminal velocity. But when the skydiver opens her parachute, the extra area of the material increases the air resistance and she loses speed rapidly until the forces are again in balance at a greatly reduced terminal velocity. So I know there might be many questions coming in the mind. Say for example, if air resistance balances her weight, why doesn't a skydiver stay still? Because if she wasn't moving, there wouldn't be any air resistance. And with only her weight acting, she would gain velocity. So the Newton's law states that if no force is acting on it, an object which is moving will keep moving at a steady speed in a straight line. And if an object is stationary, then it will remain stationary. So another question, surely if she is traveling downwards, her weight must be greater than the air resistance. That is only if she is gaining velocity. At a steady velocity, the forces must be in balance, and that follows from Newton's first law.